Today is December 6th. It is a bee day. Today's question is, how does natural selection give giraffes their long necks? You will be taking a benchmark on December 18th and the 19th. For the last 3 minutes, you are working in your groups, with your pair, and explaining the cartoon. The first picture shows the three birds, and they're only eating what color beetles? They're only eating green beetles. And the reason for that is in the caption. What does it say, Trayvon?
Green beetles, our favorite.
Thank you. The green beetles are the favorite. So what can you infer about the orange ones?
They don't like the orange ones.
Yes, why not? They taste
Disgusting.
they probably taste disgusting, or they don't taste as good. They're not eating the orange ones. Now, shh. You need some prior knowledge before we start. All organisms initiated from one original organism and needed to reproduce in order to make more of their own kind. When they reproduce, they copy their DNA. Sexual reproduction, we cross genes. But how do we get new traits? How do we get new traits if we're copying our DNA? When we cross the genes, there could be hidden genes, but initially, how do we get a new trait? Sit right here for now, baby. How do we get a new trait? Right, a mutation causes a new trait. So if all the beetles started off as green, and the green ones were the only ones eaten, the green ones had little competition. So when there's not a lot of competition, they can eat whatever they want. The only thing they have to worry about is being eaten themselves. But they'll be able to reproduce. A mutation comes. And orange beetles now are the mutant. There's a new color. A new trait was developed. Now there's orange ones. There's competition amongst the orange and the green ones, so they all have to compete for the same food. However, the blackbirds, there's no competition because they don't like the orange ones. They're disgusting. So they only eat the green ones. This doesn't happen overnight. It takes a very long time, lots and lots of years. So they're saying generations later. This probably happens over the course of 100 years. And what's happening to the orange beetles? They become more prevalent. What does that mean? They're more popular. There's more of them, their population. The green ones become less prevalent, Trayvon. What does that mean? There's less reproducing. They're lower in numbers. So they have to compete more with the orange ones for food. Plus, they have to hide and compete for shelter and everything else because they're the food of choice for this organism. Eventually, over time, what happens? There's only orange or red beetles left because the green ones were not able to compete. They weren't able to survive. So all in all, what do you know about the orange beetles? What do you know about the orange beetles, Vincent? They are. Why? That's perfect answer. They are superior. Why, Mr. Edwards? Okay, chemicals inside of you are some type of trait, right? A different trait. They taste disgusting. They have better traits to help them survive. So we call these traits that help you survive. Starts with an A. Do you remember this from Red Car? From the Red Car. Adaptations. The orange beetles have better adaptations for their environment. The orange beetles are better suited to survive. They have better adaptations. This unit is all about survival. Survival in your environment. So this is what we're writing down in our notebooks. The orange beetles are better suited to survive in their environment. So this goes back to our question. How did natural selection give the giraffes their long necks? Think about the term natural. If something's natural, what do you think happens, Emily? Yeah, they had to adapt, but doesn't happen. Look at how many years it took. Keep going. They have to adapt to their environment. These are the giraffes. Look at them. 25 million years ago. And then, how do we get a new trait? The only way we get a new trait is through a mutation. So there was some mutation that occurred, and it was able to be passed on because it didn't kill them. They didn't die. So 16 years later, they evolved into something a little bit different. Another mutation occurred. Actually, two more mutations occurred, and now we have two different organisms. They branch off. But this took another 9 million years to occur. This one took 14 million years. And today, 25 million years later, this is what the giraffe looks like. It took 25 million years. This is an okapi, which is an ancestor. They're all related to the original giraffe, but mutations occurred because their environment changed. They don't live in the same places. They have different foods they eat. So they're able to survive because of their traits, their adaptations, their features. The giraffe can survive in its environment now because it's adapted well, has a very long neck. Yes, sir. This right here is I can't even pronounce this, but it's extinct now. It's no longer in existence. Most of the organisms that were on the earth at one point are all now extinct. Why did they become extinct? Because the environment changes so often. 10,000 years ago, there was an ice age here. And we were under ice. We're actually a product of a glacier. Long Island was pushed and pushed and pushed from a glacier, and we're remnants of a glacier left behind. It's predicted that 10,000 years from now, we'll have 300 feet of ice on top of us. Will we be living on Long Island? Not us particularly will be dead, but humans in general probably won't be living on Long Island. We'll probably have to move south if we can. We might not even be in existence anymore because of the way we fight in this world. Mr. Mallon. At one point, that was going back millions of years ago, all of the continents were shifted together, you are correct, called Pangea. The Earth is on tectonic plates, and those plates have little cracks in them, almost like an apple pie when you cook it for a while, how they crack, like you drop Humpty Dumpty, the egg, and they're little cracks. And the Earth inside is really hot and it's moving, so the plates move a little bit and it shifts the continents. Everything is shifting. So in about 250 million years, the Atlantic Ocean is probably going to be opened up even more and pushed aside. We're going to have a bigger ocean and a smaller, other oceans will be smaller. We didn't go that fast. It was probably like 12,000 years. But there are years that will transpire in between them that other organisms that they didn't put there. They have to find more and more fossils. However, I think it's the rate of reproduction and survival rate. We survived. We're more civilized. We're smarter, so we're able to survive and reproduce faster. And we're able to, I guess, so when we reproduce faster, our genes will mutate more. But we don't reproduce the fastest. What organism reproduces even faster than us? Really, really fast. One-celled organisms called bacteria. They can evolve so much faster than us, and the proof is in the antibiotics. We have to constantly change and up the antibiotics. Years and years and years and years ago, we used to use penicillin to kill certain bacteria. It doesn't work anymore so well because the bacteria mutated, changed, and now it requires stronger antibiotics. That's why doctors hate to give you antibiotics when you're not really sick, because they don't want you to kill off the good bacteria, and that'll change the bad bacteria's genetic makeup because it'll be harder for it to survive. Hurry up. All right. Take out your yellow notes. We're looking at the term called evolution. Now, this is a very controversial topic, and a lot of people have religious beliefs, and the religious beliefs will supersede anything that I tell you, except you just need to know this as science. Do you have to believe in this? No. You just have to look at the evidence and read about it. Like, there's so many different religions out there. There's Buddhism, there's Hinduism. You don't have to practice those faiths, but you just have to learn about it. So we're learning about evolution. So if your religion says otherwise, please believe in your religion. I'm not going to change your mind. Hold on, let me help you. Thank you. Okay, bye-bye. Giselle, attendance, baby. All right. So we're looking at changes over time. We're looking at the evolution of the cell phone. If you look at the cell phone, it's changed drastically to meet our needs, and keep that in mind. All organisms change based on their needs and their environment. The computer has changed drastically too. Yes, sir. They were big because of that. That was the technology we had. The horse evolved, but the horse took millions of years to evolve. Over 25 million years, the horse changed. If you look at the first horse, it's over on this little side over here. It has toes. 1, 2, 3, 4 little toes. And it has small little teeth. And the origin of the horse, the actual size of the horse, is very tiny. And over time, it gets a little bit bigger. And the function of its feet changes. It has a different amount of toes, and it progressively gets less and less, and then finally there are no toes. We only have hooves now. And we have big, flat teeth. And the reason why those things changed is because the environment changed. Their jobs changed. The need for those things changed. We have appendix. Mice use their appendix all the time to break down nuts and different herbs and plants. We can't use our appendix. We don't use it. Did we ever use it at one point? It might have been useful to us as Neanderthals, but now it's not. So those things are starting to, the organs that we have are starting to disappear. So if somebody was born tomorrow without an appendix, and that was a gene, and that was a mutation, and then they reproduced, they would have children without appendixes. But it wouldn't take 10 years for that trait to be passed on. It would take thousands of years because those people had to reproduce, et cetera, and then the original people had to die out. So it probably take like 20,000 years for everybody in the world to change over, or even more. So that one little change. So mutations that are going to occur, if they're beneficial, it'll take a long time for it to populate. Yes, sir. How small was it? I think it was about the size of a dog. Like a small dog, maybe. Yeah, maybe. I was thinking about a pit bull, but I think it's even smaller than that. I can look it up later. All right, let's proceed so we have enough time. I love the evolution of video games because today I watch my kids play video games and it looks like they're watching television. When they play that basketball game, what's it called? Yeah, it looks real to me. And I always think, I'm like, who's playing? They're like, me and Brian. I'm like, oh, okay. So when I was a kid, this is what my Mario Brothers, everything looked like this. Donkey Kong, Mario Brothers, it was very pixely when I played video games. And it was still fun back then. Atari, it was very pixely. We had Space Invaders, and there were just little lines and go back and forth. Pac-Man, Donkey Kong. I remember I had a game system called Intellivision, and I thought it was so cool because the graphics were better than my friends that had Atari. So it was cooler to play at my house. But now, all the graphics are they're really good because we've learned how to manipulate the technology. So let's look at your notes. You're writing what's yellow. First page, baby. Most life forms evolve. That means they're going to change over the course of millions of years. So in reality, Kevin, the first human fossil that was found was over 3 million years ago. And from that time, we've evolved. It took us 3 million years to evolve to what we are today. About 12,000 years ago, there was another species, perhaps, that existed at the same time as us, the caveman, and they might have even coexisted with us and then died off. We were a lot more civilized, so we were able to survive. What we do is we change our environment to meet our needs. These organisms don't have the ability to change their environment. They have to deal with it. If they're born albino, they can't figure out a way to hide themselves. They might be smart enough to hide, but most of the time they're not. If we're born with a deficit, we get glasses, we build ramps, we put people in wheelchairs. We fix the environment so that the people can survive. How many dogs have glasses? They probably could, but we don't give them glasses because they're not civilized like we are. They don't have the function. They don't have the need for the glasses, right? Because we'll help them. They don't really do much for us. Service dogs, we would pick another dog then. If it didn't do its job, they wouldn't be able to do its job. We'd have to pick another dog. Yes, sir. Oh, dinosaurs. What would another example be? How about the woolly mammoth? Would be an example. Saber-toothed tiger. Can you think of another? A megalodon? A big shark from a long time ago? Mario? You could say Mario. Yes, sir? I'm calling you, Juan. Your dog evolved from wolves, but we actually made dogs. The dogs that are smaller are because we selectively bred them for their size. So when there was a mutation, we took that dog aside and we said, we like this mutation, we're only going to breed the small dogs now. So we actually made all those breeds. Every single dog is man-made. Humans domesticated dogs and cats. We even domesticated pigs and horses. There are wild horses out there, and we've domesticated some horses, and we train them to be tame, but we don't pick the ones that are untamable, right? The wild ones that can't be tamed, we don't use them. We don't breed them. So we actually made the subspecies of certain animals. All right, we're going to look at some evidence that shows why evolution probably does exist. I don't know if I should put this video on, but I don't think it comes out good. All right. I'm putting it on for you, but I don't know if I should put it on the video. Shh.
Stated clearly presents. What is the evidence for evolution?
Okay. Shh.
The theory of biological evolution makes two very bold claims about living creatures. First, all living things on Earth are related. They evolved from a common ancestor.
Okay, if we're all related and we evolved from a common ancestor, where did everything come from? The first organism that ever existed was probably a very simple unicellular organism. Can you think of the simplest organism today? Shh. What do you think, Vin? Bacteria, you are correct. So if this theory is correct, we all evolved from bacteria, and mutations occurred to make us more complex. So the first organism probably didn't exist 4.6 billion years ago. We only have evidence of a couple of billion years ago, maybe like 2 billion years ago. So for several billion years, there were no organisms on the Earth.
Second, the evolution of living things is powered by natural processes, things which can be studied.
Okay, so tell me why this organism wasn't eaten. Shh, thank you for raising your hand, Rachel. It has, camouflage, so it has a specific what? What's the term we're looking for to describe why? What's it called, Mr. Edwards? Well, evolution is the process that helped it survive, that made it change. It had a special trait, and that trait helps it survive, starts with an A. It's called adaptation. Good job.
And understood. But is there really any evidence that these two claims are true? Yes. There are so many observable facts from so many different fields of study that the only way we can even begin to talk about them is to group them into categories or lines of evidence. To keep things simple, here we'll focus on evolution's first claim that all living things on Earth are related. We cannot tackle the entire tree of life at once. After all, there's an estimated 8.7 million species alive today. So instead, we'll focus most of our attention on one fairly small but fascinating branch of the evolutionary tree, cetaceans. This branch includes whales, dolphins, and porpoises. Biologists tell us that all these creatures are closely related, and that the entire group evolved from an ancient four-legged land mammal. Instead of taking their word for it, let's look at the facts. We'll start by looking at a few from the field of comparative anatomy, the study of differences and similarities between living things.
When you're comparing your anatomy with
Whales live in water, and from a distance, they sort of look like giant fish. A close inspection of their anatomy, however, tells us a very different story.
They even have little feet over there. Look at their
Whales,
legs.
just like land mammals, but unlike fish, have
And they have
placentas and give live birth. They feed milk to their young. They are warm-blooded, which is extremely rare for a fish. And whales do not have gills. Instead, just like us, they breathe air with 2 fully developed lungs. Whales don't seem to have noses like mammals do. Instead, they breathe through blowholes coming out the tops of their heads. Some whales have 2 blowholes which almost look like nostrils, but dolphins and porpoises only have 1. Surprisingly, if you look at their skulls, you find that the blowhole splits into 2 nasal passages inside the head. Could it be that the blowhole is actually a highly modified mammal nose? It looks that way, but we'll need more evidence to be sure. Many whales have hair, just like land mammals. In this photograph, you can actually see the whiskers of this baby gray whale as he rests his chin on mama's back. Strangely, whales have arm, wrist, hand, and finger bones inside their front flippers. Here's a photo of these bones, the same bones that bats,
Humerus,
hippos,
ulna,
and
radius.
people have in their
These are your
front appendages.
carpals. You know how people have
1
carpal tunnel?
bone,
These
2
are the bones
bones,
that are affected with the
wrist,
muscles.
hand, and finger
Your
bones.
phalanges, they're very similar to humans. Look at how similar they look.
Modern whales do not have back legs, but they do have a strange pair of bones where the hind legs should be.
And they have hinge joints.
Here's a picture of these bones from a bowhead whale. They almost look like shriveled hip, thigh, and shin bones. This one even has a ball and socket joint between the hip and thigh bone, just like the ball and socket joint in your own hip. Is this resemblance a mere coincidence, or are these real leg bones? Perhaps leftovers from the whale's evolutionary history. Before we draw any bold conclusions, let's see if a completely separate line of evidence will confirm our suspicions. Embryology is a study of how creatures develop.
Do you remember when we did the gametes and we had to count the chromosomes, put them together to tell which organism you had? All of the embryos looked almost the same. They looked alike. Why is that possible? Why do they look alike, Em? Yeah, because we're all related. This is another piece of evidence. I want you to look at the different organisms they're showing you. Embryology, most of the embryos look very similar to human embryos. It's kind of scary.
Before being born or hatching from an egg. Here we see a dolphin and a human embryo side by side at similar stages of development.
They're very similar.
Notice that they both have what look like arm buds and leg buds. In humans, the leg buds grow to become legs. In whales, they grow for a while but then stop, effectively fading away as the rest of the whale continues to grow.
Gracie, turn around.
These are all photographs of a common dolphin at different stages of growth. Notice that early on, we see 2 nostril grooves on the front of the face, just like you'd expect in a puppy or a human. As the dolphin continues to grow, the nostrils migrate to the top of the head and fuse together, becoming the dolphin's blowhole. So far, we have multiple facts from 2 independent lines of study, comparative anatomy and embryology, that are both telling us the same story. The ancestors of whales were once 4-legged land creatures. Will the fossil record act as a third witness, confirming this idea? These are 2 species of extinct basilosaurid whales. These animals are known from multiple well-preserved skeletons, and they appear to have lived side by side roughly 34 to 40 million years ago. In this photograph, we're looking down at the top of a basilosaurid skull. This is not a model or a cast. These are the actual bones which were pulled from the ground. Notice that the nasal opening is not on the top of the head like those of modern whales, and not at the end of the snout like those of land mammals. Instead, it's right in the middle. This is an intermediate species, exactly what evolution tells us we should find. At the back end of a basilosaurid's body, there are small, yet fully developed hips, legs, ankle, feet, and toe bones. These legs are far too small for walking on land, but they may have been useful while mating, or for scratching away parasites and itchy skin. Evolutionary theory tells us that the further we go back in time, the harder it should be to distinguish whales from normal land mammals. Meet Myocetus. The hip bones of Myocetus seem sturdy enough to walk on land, but this animal is considered to be a whale for many reasons. Their skeletons have all been found among fossils of sea creatures, which tells us they lived in the ocean. Their short legs, combined with long, flat fingers and toes, suggest they were strong swimmers with webbed hands and feet. Here we see the bottom side of a Myocetus jaw and skull. Her teeth match those of the basilosaurid whales we saw earlier, and the unique structures of her middle ear bones match those of basilosaurid whales and modern whales. Myocetus appears to be a walking whale. Scientists have found the fossils of many ancient whale-like mammals and continue to find more. Together, these fossils blur the line between four-legged land mammals and fully aquatic modern whales, solidifying the idea that whales indeed evolved from land creatures. Now let's look at a fourth line of evidence, DNA. DNA molecules contain chemical codes which act like recipes for living things. Without ever looking at bones, embryos, or anatomy, researchers can compare the DNA code of different living creatures to find out who is most closely related to who. Whale DNA has been compared to all kinds of other animals, fish, sea lions, you name it. And so far, the closest genetic match is to the pudgy, water-loving hippopotamus. This does not mean that whales evolved from hippos, but if this genetic finding is correct, whales and hippos both evolved from a common ancestor that lived roughly 54 million years ago. At first, the link between whales and hippos surprised researchers because whales are mainly carnivores. They eat things like fish and small crustaceans. Hippos, on the other hand, are mostly vegetarian. A closer look, however, reveals that hippos and whales actually share many strange features, some of which may have come from their common ancestor. Ancient walking whales have specially shaped ankle bones found only in hippos and the close relatives of hippos. Just like whales, nurse their